Hello everyone. Today I am going to discuss relationship between current and magnetic flux. Current may be either DC or AC. Further, we're also going to discuss reluctance, magnetomotive force, which is also known as MMF, saturation level, and various characteristics curves for relay. And of course, there are some questions based on my today's discussion. So, our interest is to learn what is flux and what is the direction of torque in shaded pole structure, which we already discussed in our last lecture. So, current and flux basically they are directly related to each other. In this context, I would like to ask you a question. What is reluctance? Reluctance is basically a position offered in a magnetic circuit to magnetic flux specifically. In other words, it is ratio of magnetomotive force to the corresponding flux. Its SI unit is ampere turns per Weber. The reluctance of the magnetic circuit is directly proportional to the length of the conductors and the inversely proportional to the cross section area of the conductor. It represents the opposition to the magnetic flux and depends on the geometry and composition of an object. Indeed, magnetic reluctance or magnetic resistance is a concept used in analysis of magnetic circuits and it is very important. I also recommend all the students should solve some questions to determine the reluctance of a magnetic circuit. Further, an important point all the students would need. Air exhibits reluctance 50 times to 5000 times greater than that of magnetic materials. Why? Generally, non magnetic materials such as paper, wood, or similar material, they have about the equal value of reluctance as air, which may be plus minus 1%. Now, next question comes, what is MMF or magnetomotive force? Because during our discussion about reluctance, we used this term magnetomotive force. Then, indeed, this term is very important to know. What is magnetomotive force? Magnetomotive force is the force that sets up a magnetic field within and around an object. Its unit is ampere turns. The magnetomotive force is considered to a number of turns of wire carrying an electric current. It is an scalar quantity. In this series of discussion about reluctance, magnetomotive force, next question comes, what is saturation? Saturation is the state when an externally applied magnetic field, which is normally denoted by H, cannot increase the magnetization of the material further. Of course, different magnetic materials have different saturation level. The saturation level may be nearby 1.5 Tesla, or you can say between 1.6 to 1.8 Tesla normally, depending upon the type of magnetic material like steel, iron, or any such material in the application. So, you need to solve numericals for determining net reluctance of a magnetic circuit, then flux in the different parts of the magnetic circuits, because this is very important and usually similar questions are asked in gate examination. Characteristics curve for current relay. You can see four curves here and they are for inverse time, inverse definite minimum time, very inverse time. It is very important point to note down. Basically, in a similar magnetic circuit, I mean to say that the appearance of the magnetic circuit is same. Yes, the saturation level of the magnetic circuit is different, and thereby we can obtain these different types of four characteristics. Here we can see in inverse time characteristics, the saturation is achieved at a minimum value of the time, whereas in the second characteristics, inverse definite minimum time, the saturation level is achieved after longer time as compared to the inverse time. And as we move towards very inverse and then extremely inverse, so you can see the differences of saturation level in a magnetic circuit. So we need to understand what is saturation level for a magnetic material. It is very important term. Now in this circuit, so now you can easily understand that selection of different magnetic materials will influence these two fluxes and will change the operating characteristics of the relay. So in field, basically the relays are designed as per the requirement of the protection scheme. So earlier talked about this torque that is proportional to the two magnetic fields. Then the sine value of the angle difference of these two fluxes. So here you can control this value of torque by controlling any magnitude of flux. You can control the angle between these two fluxes, and thereby you can easily control the torque. I hope you understand this explanation. Now my question is, what is the direction of the disk rotation? The direction of the disk rotation is from unshaded pole to shaded pole. You need to think upon this question because your unshaded pole flux leads the shaded pole flux. So you have to see when your angle theta is positive or when your angle theta is negative, because that makes the torque positive or negative. Can a control spring provide control torque? Yes, it can provide. Next question, as the disk moves towards the closing of the contacts, the spring torque increases slightly with the winding of the spring. How is it balanced by operating torque? Can a spiral shaped disk solve this issue? I hope you can find the answer of this question quite easily. Just try. What is control torque? The control torque is normally provided with the help of a control spring, which is attached to the spindle of the disc, and the disc is usually made of aluminum. As the disc moves towards closing of the contacts, the spring torque increases with the winding of the spring. The relay disc is so shaped that as it turns towards the pickup position, closing of the contacts, there is increase in the area of disk between the poles of the actuating structure, which causes increase in AD current and thereby increase in electrical torque that just balances the increase in the control spring torque. Hence, the shape of the disc usually is that of a spiral. I also suggest students to see the aluminum disc, which also has dots on its surface. So you need to think why such dots are provided there on the aluminum disc. Since the shape of the disc is not perfectly circular, hence you can also find a balance weight kept on the disc surface. This suitable balance weight is provided on the part of the disc which has a smaller area. Damping torque. This torque is also very important, and damping torque can be provided by any way, either using air, fluid, or AD current. In induction type of relay, the damping torque is normally provided by a permanent magnet of high retentivity steel. It means the permanent magnet is made of high retentivity steel. The purpose of this torque is to provide a control on the motion of the disk. The motion of the disk can be controlled by adjusting the position of this magnet. Thank you.